Welcome to today's spotlight session on computer science for software development, a program offered by the Lausanne School of Engineering that takes place at York University's brand new Markham campus. Now, whether you are joining us live or watching this on demand, we want to start off by thanking you for taking time out of your day to really explore and learn more about this exciting program. I'll start off with a brief introduction. My name is Anna. I'm the Domestic Student Recruitment Officer here at Lausanne, and I work directly with students like you to help you navigate the application and admission journey, as well as to help you learn more about each of our programs so you can find the best fit for you. As you can see, I am not alone today. I'm joined by Professor Larry Zhang, who will guide you through this program, talking about some of the courses and skills you'll gain, as well as opportunities offered at Markham campus through the computer science or software development program. Again, we hope that you'll learn more about today's program, as well as it'll pique your curiosity so that if you have any questions for us, we'll present some ways at the end of today's session to stay in touch and hopefully you will join us for future sessions as well. Now, without further ado, I'll hand it over to Professor Zhang to kick things off.
Thank you, Anna. As Anna mentioned, we'll be talking about our computer science programs at York University's new Markham campus. My name is Larry. I'm the vice chair of the EECS department and also the program director of our computing programs under the Lausanne School of Engineering at the Markham campus. So here, at the beginning, a bit of a big picture first. I think that the York University's new Markham campus and also our computing program is, I think they're created at a very strategic location and also a very interesting time. Right? The location of it, the Toronto area, the Greater Toronto area. If you think about it, it's definitely has been and it's going to be the high tech like a hub capital of Canada, and potentially it can grow much bigger to something that's in on the similar level as Silicon Valley, right? Because I said interesting time because this program, basically this decision that we're going to open a new campus at the Markham, so was before ChatGPT, right? It's before and then while we're working on the establishing the new programs, basically the launching of the program was actually after ChatGPT. Basically, we're entering this age of AI-led industry revolution. So it's a very, very interesting time to create a brand new program as well. So an overall bigger picture of the kind of the guidelines that we have in mind for this new program. First, want to this program to specialize in the most critical technology domains in this era of computing. It's going to be a new era of computing, and the way we teach the curriculum here, we want to because we're new programs built from scratch, we actually have the advantage of doing a lot of the innovative pedagogical things in our programs, right? Because many of the things are very difficult to do in a well-established big computer science department because we're building things from scratch anyway. We have the luxury to do a lot of innovative teaching in our programs. And also one big emphasis of our program is what we call industry-ready education. Basically, make sure students graduating from our program, they're actually fully ready for industry, for the job they're gonna take after they graduate. So that has been a challenge in higher education for many, many years. I think it's a never solved problem, but we have a unique opportunity here to do something really, really innovative and effective about it. So overview of the programs we have at the Markham campus is under Lausanne School of Engineering. We have the main topic today is computer science for software development. And it's basically a computer science program designed, like I said, for the more than the next era of software development, right? We have specialized, we don't try to be a very broad computer science because computer science has grown to be a really huge area. We don't try to be a comprehensive big department covers everything in computer science. We try to specialize in the domains that are what we actually we work with industry partners to identify this key area for the next area of the industry, cloud computing, cybersecurity, data science, and AI. These are the most important areas in the industry for the foreseeable future. And we try to focus on really have a very specialized focus on these areas. So overall, that's kind of the design idea of the program. Alongside CSSD, we also have another program called Digital Technologies, which is also very innovative, very new kind of program. It's Canada's first fully work integrated learning program. By fully work integrated learning, we mean the students in this program they will start their basically full-time job working in a company starting from year one, right? That's a very special program. But we can probably have other opportunities to talk about that more in detail, right? So this is also essentially a computer science curriculum, but students will be just working and studying at the same time for the whole 4 years. But they also have specializations in software development, cybersecurity, and data science and AI. And the founding principles or the design principles for both programs, all the both new programs we have in the Markham campus, we really try basically everything was built from scratch, right? So we really try to adopt the latest state of the art in the field, right? We built a very forward-looking curriculum to make sure what we teach the students is actually um, the most relevant knowledge and skills for the next area of computing. And we have a huge emphasis on hands-on project-based experiential learning, right? So we try to do less of lecturing, passive lectures, just students listening to profs talking a lot of time. And we try to make students do things by themselves as much as possible, right? So hands-on project, but we make students do projects, do real projects, and uh, maybe real projects potentially from real industry partners, right? The real kind of a real project in real businesses, and try to make them do things whenever possible, right? And we have again we have this huge emphasis on industry ready education. We really prepare students for their jobs, meaning not just the technical skills, but also many times the professional skills that's needed to be a successful employee, right? Or employee or entrepreneurship, right? Entrepreneur or any kind of basic industry that like a career you're gonna pick in the future, but make sure you're ready for it, right? Fresh off school, right? So these are the really emphases. Quick overview of the two programs in terms of numbers. For CSSD, currently we have 160 students. The digital technology, we have roughly 60 students. Still relatively small, growing, and we have about 10 full-time faculty members and plus several sessional instructors teaching all the courses. If you calculate the faculty to student ratio, it's roughly 1 to 20, probably higher than probably close to 1 to 15 with all the sessional instructors considered. So it's a very high faculty to student ratio, right? I said the word still, we're still very high because last year was even higher. Last year we had the fewer students and roughly same number of faculty. So last year was even higher, but this year we growed a little bit. It's a little bit lower, but still very high, right? In the typical like a big computer science department, you see is this number can easily go to 1 to 50, 1 to 80. So 1 to 20 right now is very high. Uh, faculty to student ratio. I mention this because I think one of the most valuable resources in at the university you're attending is how much time share of a time you have with of your professors, and do you have opportunities? How big opportunities you have to speak to them, maybe about the courses or maybe even about more general things to listen to. Hear their thoughts about the future of the field, right? I think this is probably one of the most useful, most valuable things, most valuable experience you get from university. I think with the temporary really high student to ratio, I think this is really a perk for the first few cohorts of students to this new campus and new program. So I think that's again a uh, unique and temporary perk for current prospective students. And like I mentioned, everything about these two programs was designed from scratch. We didn't try to copy and paste any existing existing kind of like I didn't curriculum from any example at all. Just we try to do everything from scratch, thinking about what is the right way to do it, right? So all the courses are created from scratch and with built in the kind of state-of-the-art pedagogical approaches and also promoting our design principles, experiential learning, and industry education. So you can imagine it has been a lot of work in the past several years. Even before the new campus launched, we started working quite a few years ago on these. And here, yeah, quick show of the pictures of the faculty members, faculty staff members of our new programs, right? It's something I'm showing because I'm quite proud of it. We really put together a very strong team of researchers and teachers for this new program. Like probably all of them have very extensive experience, probably more than 10 years of experience researching and teaching in the field. And yeah, I think it's a very nice, very strong team of faculty teaching team that we have at university. And we for which you have a very high student to faculty to student ratio to and access to. So here's a QR code that's pointing to a kind of web page with a quick introductions of each of the faculty. You can see for yourself. So it's actually a very impressive group of professors teaching in this program. And the degrees, right? Just a quick look of the kind of degrees you potentially will get from these two programs. For CSSC, we have two options. One is the Bachelor of Applied Science Honors with 100 basically a 4-year, 120 credit degree. It has a co-op option. You can kind of choose. And in the upper years, the program diverges to kind of three different specialized streams: cloud computing, cybersecurity, data science, AI, basically. Yeah, you can choose courses in different areas using in any combination you want, right? So this part will keep things quite flexible. Uh, and if for any reason you're in a hurry, you can potentially finish the degree in after 3 years with 90 credits, right? So that's another option we have in the CSSC program. For the digital technologies program, we have a Bachelor of Applied Science honors with specialization, right? So this is kind of only one option. It's a 4-year degree with specialization, and the one is one of the three specializations, right? Cybersecurity, data science, and software development. So that's kind of the preview of the degree you will potentially get after you graduate. And here's a kind of a heat map of different kinds of things related to experiential learning and industry-ready education that we do in both of these programs, right? For example, you can look on the kind of it goes from experiential to more experiential. That's the kind of the scale of the how we position all these activities. At the lower end, we have, for example, the relatively lighter weighted things, guest lectures, industry panels. We are very keen on inviting people from industry, from community to join our lectures and to give students insights about what is actually going on in their company, in their like we had people coming from York Regional Police telling us about how police works on the data science aspect. So it's very interesting. So we try to avoid having the same professor teaching all the lectures the whole time whenever possible. Whenever we have an opportunity, we always try to invite a lot of external speakers to our classroom, giving students kind of real world view of what's going on. And we also have a lot of kind of on the professional skills front because here we like for industry ready education. Actually, if you ask employers what are the skills that you see the biggest skills gap that you see in the new fresh graduates from university, the majority of the employer would say is some sort of the kind of sometimes we call them soft skills, but really soft skills is somehow making them sound less important, but they're almost equally important as the technical, sometimes more important than the technical skills or the professional skills, like teamwork and communication, how you manage your project, right? Overall, be able to do some system thinking be able to like yeah network and yeah also in terms of job preparation, mock interviews, these kind of things is these are really important, and we do this in our program. And one special thing we do it we make them we have dedicated courses right in built into our curriculum, which are core requirements. So students in some sense they're forced to learn about these skills, right? Naturally, what we observe when you make them their electives on this course has been existing for a long time. But what we see is students typically they don't pay much attention if it's just selective. They don't feel motivated. They don't realize the importance of these courses. Then they don't feel motivated taking them. So many students they just would just like skip right or not taking these courses. But by in our program, we actually force them to take it, right? It's kind of this forced exposure to these professional skills uh, actually makes a big difference based on our experience so far. Students actually just even after a short lecture about how to like network with people properly, I think it makes a big difference in terms of what they actually do in real life. So these are the things almost like low-hanging fruits. As long as you try to teach people something, a big difference can be made. So this is big, actually we made them an important part of our curriculum. So to really make sure people are ready for their have the professional skills to be ready for their for also for their jobs, also for their job hunting process, right? The interviews, resumes. We have courses like workplace preparation, everybody's required to take, and we literally review our resumes and do mock interviews in those courses. I think that's a very important part of the program. And we also have other things, project-based learning, whenever basically we encourage essentially all courses we teach in here to have a significant program, project component. So a student gets to do hands-on, do things whenever possible, right? Rather than just listening and to lectures. And we have, for example, one good example is we have actually in our CS1 course, basically the introductory first computer science course we take, we have this interdisciplinary design. We have two courses basically called the coding through biology and coding through chemistry. So basically, instead of just say introduction to programming, we teach you Python, whatever. And we actually just the way we teach this, we teach you Python and you use Python to solve a problem in chemistry, a real scientific problem in chemistry and in biology. So just always putting things into real world context. You see how you use your this tool called programming language or computer to solve real life problems. I think that's a really interesting approach, right? So it's almost an analogy here is almost like instead of having a let's say if it's a program for carpentry, instead of having a course called Introduction to like screwdrivers and wrenches, we actually teach you okay, build a chair using tools, and we can build a table using tools. I think that's definitely the feel to probably be more obvious. That's actually the right way to for people to learn these kind of skills. And and also we have the co-op. This is not new, right? We have also have a we have co-ops in other program, and we have also have co-ops in this program. That's one option student can take. We also have things like a community engaged projects, right? This is actually in a in more concrete way. We imagine them basically we're in process of establishing something related to this. Basically, we imagine basically in our view computer science in this era of this, we have so much more powerful tools for computer scientists to use. Upper year computer science students, right? There should be totally capable of producing a production level software and of commercial value. We can set it to real customers. So we want to establish a platform where students, upper year students in this new program, they can actually have a place to work and take on real world contracts from real life. Cause for example, Markham Library or Markham Museum, they need to implement a little thing, software, and our students should be able to take on that contract and deliver the product and create some commercial value out of it. I think that's something very realistic and to do. And we're actually trying to make this again. It was also a great project, literally a real project, a great experiential learning and project-based learning. Uh, Also, we have courses in, like, for example, contest, showcase. That's essentially in the third year, how you have a course. Essentially, we run kind of you do some sort of the whole course. We don't try to teach you any new topic. It's just, a whole course is about the students working in groups, doing a real project, right? Could be potentially, for example, people programming the game AI try to compete with each other. We run a tournament in the course, or you do maybe some data science project, but just the whole course is about doing a big project and you get credits for it. Also, the showcase credit is required in the degree requirement. So somehow everybody's required to do it to have this experiential project-based experience. And we also have undergrad research opportunities. You can work with faculty members to uh, either deliver a research idea that's either come up by you or by the professor, right? And on the more kind of extreme end, we have research, as what you mentioned, the full work integrated learning in digital technology. That we say that's the basically the kind of extreme version of experiential learning of an industry-ready education. Basically, literally put students into workplace for real for 4 years to do the learning, right? So that's yeah, that's the kind of a flag, also a very important version, kind of very new model for computer science education, and we have lots of kind of support for that program as well. So that yeah, here's kind of just a map of all the different potential things you will experience once you start this program. And here, in case you didn't believe me, we had lots of events and industry related events. Basically, I just randomly grabbed some pictures from LinkedIn, right? If you're interested, you can follow York University Markham campus on LinkedIn. And we have yeah, these are all pictures from events just between January and March 2026, which is the past spring. We just and every picture we only grabbed one picture from each event, right? So basically, at least there are like you can see there are 12 events going on, showing different things, right? For example, we have guest speakers from York Regional Police. We have networking events with different like Markham local startups and also bigger companies. So yeah, so lots of kind of evidence of how active we're working towards this kind of industry integration in our programs. And a quick list of some of the, again, not the full list, some of the employer partners has been working with us for both DT and CSSD, right? So we have partners from like very big companies, also some medium-sized companies, also even some local startups. Also, we have like a community partners such as York Regional Police, so they are very yeah, there's very interesting things we can do together. All right, so here at the kind of last part of the final part of the presentation, I want to address one of the questions I often hear from students and parents. I also see that online quite a bit, right? So, yeah, basically people worried about the future of computer science somehow. Well, I look at all the news about these big companies laying off, like have big layoffs of their employees, right? So does that mean AI is going to replace all computer science jobs in the future, right? So here's my take on it. I think also I think most of my colleagues would agree with me on this point. So what you observe, for example, like one particular big company or a few big companies laying a lot of jobs from their company, and that's true, right? Because if you're given a particular company the same amount of business, you need to, with the power of AI, you actually need fewer humans to get your current work done. That's definitely true, right? Because AI is making every single developer so much more productive. You need fewer of them to get the existing given piece of work done. But however, if you take a little bit of a bigger picture, take a step back, if for each company you definitely need fewer people, but if you look at the whole industry, right? The whole industry, the size of the whole market, the whole industry gonna grow so much bigger, right? Because with the powerful tool like AI, it really enables so many more people to create so many more new businesses. Where if you think about the industry growth, because of AI, I think it's going to be much, much, much bigger, right? If like to put into a, it's even a little bit hard to imagine how much of growth you will see because of that. But to try to put into maybe more concrete sense, if you think about the size growth of the industry, of the tech industry before and after internet, if you think about it, right? Internet was a major industry revolution, you can call it, right? And there's huge difference in terms of the market size before and after internet, right? Think about the size of the tech industry. I'm not sure you were born before internet, but maybe you ask your parent if you have no idea. The size of the tech industry before and after internet. I think the growth brought by AI can only be bigger than this, right? I think that's basically it's almost really hard to comprehend how big growth that is, but it's going to be really really big, right? Everybody is I think is seeing that coming. So essentially, the if you think about opportunities in the field in the future, there's going to be so much more, right? Just don't just focus on one company. The opportunity for just interesting technology projects in the future, like there's the opportunity for entrepreneurship in the field is going to be much more than before, right? A single person potentially can be as productive as a company as we see today. And there's so many more software is going to be created, solving more challenging, more interesting problems. Okay, another thing that is true is that AI tools these days has become remarkably good at programming. Actually, I say especially since I say end of 2025, there's I think it was a huge jump in capability in the AI models in terms of programming abilities. That's actually really really true, right? In many ways, it can it basically can replace in some sense it can replace human in terms of writing code, right? I think that's a completely fair assessment. Also, but I think what people often not see is that computer science is really never about coding, programming in the first place, right? If you think about the typical computer science curriculum, even the traditional computer science program, if you look at it, maybe estimate across the 4 years of your study, you take roughly 40 different courses, right? Take one 5 course per semester. You take roughly 40 courses, 120 credits in total. Maybe the first maybe 2 or 3 courses in your first year they are specifically about the programming in some kind of programming languages, and the rest of the whole program the 37 other courses they're not about programming at all, right? So programming learn to program in a language is it's a very very tiny part of computer science. That's not even the main thing that you learn. It's probably the least one of the least important things I would say. It's not important. It's important you have to know how to use the tool to do everything else. But definitely not the most interesting topic you're going to learn in computer science. There's so much more. You learn about, for example, cybersecurity. Learn about how systems are built. You learn about how data, what is the math behind all this data science, right? There's so many different things you can learn. And there's a famous quote I always use is from one famous computer scientist, Dijkstra, is computers to computer science is no more than what telescopes are to astronomy, right? Just like if you want to be a graduate in astronomy, of course, at the beginning you have to learn how to work with the telescope, how to use it. But astronomy is not about telescope, right? If you basically if you it will be if you call bas astronomy is about the science of the universe, right? That's the thing you're learning, right? So basically, to me, that's actually I always tell people, to me, the naming of computer science was a bit unfortunate in the sense that it almost feels like you're naming astronomy instead of naming this field called astronomy, you call it telescope science, which completely doesn't make sense, right? So, but has been there for many years. We don't try to change it. But yeah, somehow I felt it's a bit unfair as a computer science because all these other fields they get a nice word like astronomy, anthropology, psychology, geology, right? They all have this nice word for it. But as for computer science, some people at some point some people just decide, oh, let's call it computer science. That's it. Well, yeah, we didn't should have paid more effort in that naming. But anyways, we were okay with it. Everybody know about it now. It's hard to change now. Uh, Yeah, so that's like a really important thing, I think, for people who even before entering a university's computer science program, this is something they're unlikely to see the big full picture. But from our point of view, that's quite obvious. It's not about programming at all, right? So computer science is not about programming at all. There's so many more interesting things you can learn. So overall, to sum it up, a well-trained computer scientist, right? Meaning you go actually spend the time and effort, go through a 4 year university training. The proper computer scientist, there with all these powerful tools of AI and other things, is you're gonna be uh, more empowered than ever. So the things you will be able to create and be able to build and the problems you'll be able to solve in the future is gonna be much more than what you see today. So that makes it actually makes the field more exciting than ever, really, right? And if you just a final question, basically, instead of the question say, "Oh, are AI going to replace computer science jobs?" So there's actually a much easier to answer question to me. Basically, if you think of, just simply ask which field of science is the most exciting today, having the greatest impact on humanity, and it's really shaping the future, right? It's shaping the future of business, shaping the future of medicine, shaping the future of art, right? Shaping the future of so many different, basically all aspects of human life, right? Computer science is really the science right now, at least right now, is the science that's having the biggest impact and really shaping the future of everything. And yeah, so if you think about that, it's kind of bizarre. People are worried. Oh, is the computer science degree worth the effort now? It's the answer should be quite clear. Okay, just final slide. Just this is, I think, a screenshot of the homepage of York University Markham campus back at when it was launching in fall 2024, and it had this slogan on the page said, "The future of learning has arrived." I think maybe to many people this maybe just feels like a hype, but for us who are actually working here, I think that's actually a very accurate description. Actually, what we are doing at the Markham campus is really we're trying to given this great have a very unique opportunity, right? You don't have this opportunity at all across the world, building a completely new computer science program from scratch. This is very unique, probably very unique in Canada and also all over the world. To build something at this very interesting time of industry revolution, build a new program that's actually with the future of the field, future of the education and the future of the field in mind. So this the future of learning really, I think that's really what we're working on. And here again, two QR codes for CSSD and DTH. Feel free to. I'm sure you can also find it on online other ways. And that's my presentation. I'm happy to take any questions you may have, or if you are watching the recording after the event, feel free to contact us. I think if you can find the contact method to ask us in any other channel with your questions. We're happy to answer you anytime. Thank you.
Thank you so much, Professor Zhang, and thank you for all those who took time out of their day, like I mentioned earlier, to join today's session. Now, of course, today's spotlight session is coming to an end. However, as Professor Zhang mentioned, the conversation doesn't stop here, right? We want you to feel welcomed. We want you to feel supported every step of the way. So we invite you to take part in the many ways that you can explore computer science for software development further, as well as explore Markham campus further. So whether that's joining us on campus for a tour, joining us on Discord to chat with current students and incoming students like yourself, or viewing other spotlight sessions that will be taking place this season. Again, thank you all so much for joining today's session. We hope you have a wonderful rest of your day. And if you have any questions, we're always here to support you. All right. Thank you very much, everyone. Take care.
Thank you.